A couple of high-level stats that I'll go through very quickly. We're seeing doubling of the investment in AI in Australia. We're still seeing, this is a statistic from a month ago, that still 95% of corporate AI pilots fail. And it's expected that 40% of agentic AI projects will get pulled before 2027. So we're seeing a lot of money go into this. We're not seeing the results that we have expected yet. In Datacom, one of the things that we wanted to do is like, how do we make it real? How can we give everyone tangible benefits over their AI implementations? We kind of started to take a look at what is the key thing that we want to achieve. And the key thing that we want to achieve is how can we augment our workforce with agents? How do you maybe not have to hire a BA, but how can you spawn that BA into existence, making your organization or your department scalable? Today we're going to take a look at how we do that within AI legacy modernization. So if we take a look on the right-hand side, AI for productivity, we kind of see you start on your journey, you have a human asks a question of a model, which is an assistant, like the Copilot implementation. The human is still the stimulus to the model. You ask for something, you get a response. Then in the second one, we kind of see teams of agents. You write some code, you take a look at policies, the human is still the stimulus. We started investing in an agentic system where we could just spawn an entire Scrum team with a developer, with a BA, with a project manager, where the developer and the project manager manage the work, execute the work, and then go to people at the end of the system to basically ask, is the work correct and completed? Now, what were we seeing in legacy modernization, and why do we see this taking off so quickly for us? A lot of the departments and agencies that we work with, 60 to 80% of their IT budgets revolve around keeping these legacy systems alive. Except for that problem, 70% of these programs fail, and I'll show you why quickly. And then more than half of your vulnerabilities come from these legacy systems. You're kind of at risk, you're spending all this money to maintain it, and you want to innovate and do a lot of new, higher value things. If we take a look at the apps that you have in the legacy, your app is never better than on day one. People understand it, it has just been built. Also, it contains the least vulnerabilities, but over time, vulnerabilities increase, efficiency of the app decreases, and the biggest challenge is like the knowledge of the system. A lot of these legacy COBOL systems, we have worked with multiple people that had to come out of retirement homes to basically advise us how this was built a very long time ago. In parallel, complexity increases and the cost to modernize. Now, why do these things fail so often? It's because we are not doing a like-for-like modernization. The economical benefit of that was so low that almost in every modernization program was like we need to add new features on top and do all these additional things, but it also increases complexity. It's the tension between technical and economical. We want to layer things on top to have a strong business case, but by doing that, we introduce all this complexity, which increases the risk of failure. So what does AI empower us to do? AI gives us an amazing possibility. Because we use teams of agents to complete this work, we can say, let's do a like-for-like migration. And we'll layer all the additional features on top afterwards. It empowers us to do, and I'll show you that in a moment, to test both systems in real time to take a look, is it still the same? Is the functionality still working? Is my data still the same? Now, if we take a look from a cost perspective, what we're seeing with most of our clients is like Datacom will commercially de-risk this for all our clients. So we will give fixed fee, fixed outcomes. It's a very mature system. And what we're seeing for most of the agencies, the departments that we work with, if they go on this journey, drastic reduction of direct cost, indirect cost, which are things like process inefficiencies, hidden cost around security and compliance. We see massive reduction between 60 and 70% from moment of completion. Most of the time, there's a little bit of indirect cost that slip over into the next year. Why? Primarily because of the reason that process optimization is something that takes a little bit longer. Now, enough slideware. Let's actually show this. So we're going to take a look at a team of agents. We have a project manager, we have a tech lead, we have a business analyst, a developer, and a quality assurance. We're kind of going to take a look first of, we're going to identify all the documents, we're going to do all the BA work, we're going to, after that, create the Scrum board, then we're going to do the entire modernization of the code base, and then we're going to test it all. So we're looking now at an example legacy app. Not super complex, but as an example to just show the capabilities that we have. We set up an Azure DevOps project, but this can also be Jira or whatever other type of technology we want. We import the front end, the back end, and the database. We go create a project. Now we're provisioning our BA agent. Our BA agent comes in, we generate everything, and now we need to understand what is this app, which is very difficult because a lot of these legacy systems are not documented well. At the output of this, we know all the screens, all the APIs, all the integration points within a matter of like days for extremely complex apps. Now we can actually document that. So functional, non-functional, test plan, behavior-driven testing as well. And we generate all the documentation. We take a look, and why do we use something like Azure DevOps or Jira? Because people are used to working with these technologies. So we now have an entire overview over what are all the buttons that I have, what are all the screens. We created screenshots. We have a deep understanding over the test plan, but also the entire hierarchy around our app. And already for a lot of our clients, this is like a big win because documenting a legacy mainframe system is not the easiest thing to do, and especially getting these diagrams in real time. To give an example, we had a client that hired 5 BAs to work for 10 months on documenting their system, and they generated 30,000 pages of documentation. And it's kind of like, who is reading it? Who is synthesizing that information? We came in on a similar system of a similar size to actually do the same thing, and we were able to do the same thing in 3 weeks with BA agents and just people to validate and ensure that everything was actually documented well. Now, how does the development work? And this is where it becomes actually really, really interesting and nice. So we have our same project. We want to generate a backlog. So we kind of go generate the backlog. What is going to be our target state? We're working in Azure DevOps. We add our tokens. We save our things. We say we want to go to React from our legacy system. Now what's happening is that the BA agent, together with the project manager agent, is populating the entire board. Why do we do this? Because humans still work on these modernization projects, and a lot of humans are used to Kanban boards and Jira or Azure DevOps. We have the acceptance criteria, the technical requirements, what we're going to do in the front end. Even things that we can integrate are things like business justification. Now we deploy our developers, our testers, our tech lead, and we slowed this down a little bit because otherwise it would be substantially too quick for people to actually see all of the things that are occurring. But over here you now see in real time all the different team members working on converging the code, testing the code, making sure that everything is working. Tech lead does a validation. Development is completed. Project manager validates that everything is actually working well. And our entire board is cleaned up. It actually updates the entire audit log in real time on the user stories and on your entire hierarchy. And kind of our modernization is complete. This was a simplistic app, but we now see the new app in real time on the right-hand side. We can go through it. We can parse almost every language to every language. We have never really run into massive problems over there, and we now have our new app that we can go through and add new functionality as well. Now, the last demo that I have, and I really want to emphasize this, if you have a legacy system and you're highly dependent upon this system, and it's millions of instructions per second or whatever it is, it's very difficult when you modernize. Is it still working the same? How can you say that with almost absolute certainty? So a lot of our effort was not in how do we write the documentation alone or how do we converge the entire code base. A big part of it was how do we validate that your legacy system and your new system is exactly the same? So if we put it into your environment, that all the integrations work. Now I'll show you a little bit how our testers work. At the start, we already generated a deep understanding over what the app is, how it's structured, how it works. Now we're actually doing our behavior-driven test. We bring up in this example virtually, like at the top, our terminal, what are we doing, what are we testing? And then you see the highlights on the legacy system where it's actually in real time going through it and saying like, this is the outcomes of it. And then what we do is that we mirror that in real time on the right-hand side, where we actually take a look, are the nodes still working the same? Are the input fields doing the same? Are there any problems? And then we generate an exit report that afterwards some of our human people can actually validate if everything is working, how it's documented, if the system is up to par. Now, probably one of the final things I really want to show you, why the hierarchy of the Scrum team that we know? Why not one agent that kind of does it all, parses it all? We kind of see that over here. There's different roles because they keep each other in check. Now, what do I mean by that? A developer agent will write code that compiles perfectly and looks good and everyone is happy, but the tech lead actually validates that everything is aligned to each other, safeguards like the consistency over the entire new app, how it works, and how it should be implemented across classes and across different parts of the code base. That brings me to my last slide and probably lunchtime. For anyone that has any additional questions over how we augment workforces and legacy modernization with agents, please come to the booth. I am highly convinced that lunch is served in front of our Datacom booth, so it's like two at the same time. And I want to thank you all very, very much for listening to me just before lunch. Thank you.